So today we're going to be doing end behavior. Your objective today is that today I will be able to state the end behavior of a graph. First we'll go over a definition. So end behavior is how a function behaves at either end. Or what happens as the value of x increases and then decreases. Right? So what's happening on the ends of the graph. Right, so we're going to look at some examples. The best way to understand this is to just see some examples, right? So we'll look at some examples. So what's happening on either end of the graph, right? Actually, I'm going to tell you the proper way to write the answers. So this is the form all your answers will be in. They'll always look like this. As x approaches negative infinity, the function approaches blank, and you fill that in. And then the second part is as x approaches positive infinity, the function approaches blank. And then in there you'll put your two answers. So the first part, this part will always look the same for everyone. You're just changing out this part. All right, so let's look at an example. So we've got this graph here. So it is a parabola. Right? You notice we've got two arrows here. Remember, arrows mean that it keeps going. So we're going to do as x approaches negative infinity. So remember, our x is this line here. So negative infinity means it's going negative forever. So as x is going this way, what's the graph doing? So as we go this way, we notice the graph is going up, right? So since the graph is going up and it's got an arrow, which means it goes up forever, we say that the function approaches positive infinity. All right, so again, as x is going to the left, right? So as x approaches negative infinity, what's the graph doing? The graph is going up to infinity, right? Okay, so for the second part, as x approaches positive infinity, right? So that's the other direction. X approaches positive infinity. So as x is going this way, what's the graph doing? So if we follow the graph this way, we see that it is going up to infinity as well. So this, the function, approaches infinity, right? So your clue here is you've got two arrows pointing up, which means both of these are infinity. Right? That's our first example. So we'll do another example. We've got this graph here. So as x approaches negative infinity, so we're going this way, what's the graph doing? Well, if we follow the graph that way, it's going down. F of x approaches negative infinity. It's going down, it's going to negative infinity. As x approaches positive infinity, so the other direction, what's the graph doing as x goes to positive? Well, the graph is going down as well. So f of x approaches infinity. There we go. That's how you do those two. Now, your graphs don't always approach infinity. You don't always have arrows going down or up. Sometimes you have arrows like this one. So if you look at these arrows, they are going to the sides. So for when the arrow is going to the side, or if you have a point instead of an arrow, we're going to be approaching a number instead of approaching infinity. Let's talk about this. So as x approaches negative infinity, the function approaches, now I figure this out. So as x is going to negative infinity, our arrow is here. Now we need to figure out what number that is. Sometimes it's easy to tell what number it is. In this case, it's not so easy. So in that case, we're going to use the equation to help us out. So So what you want to do is take that equation, go to a calculator, and you want to plug in a couple things. To figure out what to do for as x approaches negative infinity, what you want to do is plug two numbers in. First, you want to plug in negative 100. Then you want to plug in negative 1,000. Right? This will help us see, as x is getting very, very small, what is the function equal to. Right? So you want to plug those two things in. So I'm going to go to my Desmos calculator. Desmos calculator actually makes this really easy for us. You only have to type in the whole thing one time. So what we want to do is we have negative 100 over, get my negative in the right spot there, do it this way. Okay, negative 100 over, and then it was negative 100 squared minus 2 times a negative 100 plus 8. Okay. As you see, we get this. So don't push enter. If you don't push enter, it actually makes it really easy. What we're going to do is first just jot down what the answer is. So for f of negative 100, we got negative 0.00979. So just jot that down. Now we want to do it with negative 1,000. So since I didn't push enter, I can still edit this. I'm just going to add a 0 to all of these. And now we know what it is for negative 1,000. So we've got this. Now, it's not negative 9.979. Because if you see there's that times 10 to the negative 4. That's a scientific notation. So it's actually, I'll show you on the other screen. So for this one, we got negative 0.00979. This was negative 9.979 times 10 to the negative 4. So it's actually that times 10 to the negative 4 tells us that there's 4 decimals in front of that number. Right? If you need a review on scientific notation, please let me know. Come to an office hours. We can go over just scientific notation if you need to do that. This is actually what we get. So this number here in red. So these are very small numbers. Anything with a bunch of zeros after your decimal point is a very, very small number. It is very close to 0. So since they're very, very small, we're going to say that our function approaches 0. Right? Since they're just getting smaller and smaller and smaller. Okay, now we'll do positive. So as x approaches positive infinity, what is our function approaching? So as you see, it is also going sideways. We need to know what it is. See if it's 0 or something else. So we're going to take our equation again. This time we're going to plug in a positive 100 and a positive 1,000. Right? So I'm going to go back to my Desmos thing. Now, I never pushed enter, so I can actually still edit this. So I'm going to just get rid of all the negatives. Okay, so here's 1,000. So you want to jot that down. And then we want to do it for 100. So I'll just get rid of 1 0 for each. And jot that number down. Okay. Oh, is not, there we go. Alright, so go back here. For 100, I got 0.01019. And this was 0.001009. Okay. So again, our numbers are just getting very, very small. So they are approaching 0 as well. This is the final answer. You always have to write this entire thing. If you just tell me the answer is 0 and 0, that is not the correct way to write end behavior. You have to write the entire thing out. So as x approaches negative infinity, the function approaches 0. As x approaches infinity, the function approaches 0. So that entire thing there. Alright, I'm going to show you another example where they x is function is approaching a number. So for this one, as x approaches negative infinity, the function approaches, and then as x approaches infinity, the function approaches something. Okay. So if we look on the negative infinity side, we have an arrow, and on the positive infinity side, we have another arrow, both going sideways. Nothing's going to infinity. We can't use these ones because they're not on the ends, right? We need the very left side and the very right side. Okay, so to test our numbers, we're going to plug in a few things. First, we'll plug in f of a negative 100 and a negative 1,000. Then we'll do a positive 100 and a positive 1,000. Right, there's our function. We'll plug those four things in. Get rid of that. So we have 3. It's always best to just get your fraction started first. It makes it easier to type. So 3 times negative 100 minus 2 over negative 100 plus 1. Okay, so negative 100, we get 3.0505. For 1,000, we get 3.005. Okay. Then we'll do positive of both. So positive 1,000, we get 2.995. And then a positive 100 was 2.95. Okay. So go back here. So negative 100 was 3.05, and then 3.005, 2.95, 2.995. Okay. So looking at our numbers here, we see that for our negative side, we've got 3.005, 3.005, 3.05. So it's just staying very close to 3, right? So if we did negative 2,000, it would be 3.0005, right? They're just adding more zeros here, so it's just approaching 3. We'll put 3 there for that one. On the positive side, it's 2.95, 2.995. So it's getting bigger. It's going towards 3 as well. Right, so that's how we do those ones. We got 3 and 3 again. So this is going down to 3. This is going up to 3. So if you look, it's going up towards 3. This is going down towards 3. But both cases are 3. There we go. Alright. So your turn to try. So go ahead and pause the video and then give these a try yourself, and then unpause it to see if you got the right answers. Okay, so for this first graph, as x is going to negative infinity, the graph is going to negative infinity. As s approaches positive infinity, the graph approaches positive infinity as well. So for this one, you want negative infinity and positive infinity. For the last one, we see they are going sideways on both of them, so we're going to want to test our equation to see what number that is. So I'm going to go to Desmos and try our 4 numbers. So it's negative 6, thousand squared plus 4. negative 3.001. I'll make them all 100. Negative 3.01. Try the positives. Get 2.984. And then try 1,000. I didn't notice. Okay, just testing. Okay, so we got our 4 things. So for the negative 100, we got negative 3.001. For 1,000, we got negative 3.01. For the positives, we got negative 2.9. And then negative 2.998. Okay, so looking at our numbers, we see these are getting, the negative side is getting closer and closer to negative 3. And on the positive side, we're also getting closer and closer to negative 3. All right. So there you go. So remember, if you have any questions about today's lesson, you can come to office hours